In this video, I will demonstrate how Deltic's Cloud Service Solution, or DCS, can be used for a fast ballpark evaluation and side-by-side comparison of the efficiency of various trade execution algorithms. This presentation is based on the research paper Simple Execution Algo Testing Framework presented on our website, so I click here to view the paper. The main question which needs to be answered in order to estimate the implementation shortfall of the execution algo is how to assess the fill price of market order depending on the order size. Of course, if historical market depth data is available, then this problem doesn't exist, as expected order fill price could be directly derived from historical order book data, regardless of order size. But good quality historical data is very expensive and in addition presents a lot of computational challenges because of very large sizes of that data. For example, in this view we can see only 1 hour of order book data for 2 future contracts, so in Eurex, and we can see that it contains more than 50,000 messages. I would say that for initial conceptual design of execution algo and ballpark comparison of the efficiency of various execution algos in different market conditions, I think that the usage of order book data is excessive. For that purpose, we propose to use the extended bar, sometimes we call it enhanced bar, which is one of the key foundations of Deltic's DCS. And instead of 50,000 messages for 2 instruments during 1 hour historical window, we will deal only with 120 messages. At this point, I would like to start Quant Office DCS and click on Market Symbols. Now I click on View Data command and process to 1 minute equity stream. We process terabytes of raw tick data from IDC, and in addition to standard close, open, high, low, and volume information, we aggregated millisecond-based timestamps of open, high, low, close trades, and then total amount of trades, which is message count, with best bid and best ask at the end of the bar. Using the enhanced bar, we will be able to get an estimate of the moving average trade size, and for this demo, I will use a simplified liquidity model by estimating that the size the top of the book is for bids and for asks is twice the moving average trade size, and level 1 will be 4 times the average trade size, and then level 2 will basically have a limit of very large sizes. Next, I would like to quickly introduce the source code of the model. Let's open the strategy designer. In this strategy, I will compare the implementation shortfall of 4 execution algos: the benchmark algo, the minimum impact algo or TVAP, limit to market algo, and I also added VWAP algo. Each algo is implemented as a separate class. The code of strategy is actually not so difficult to read. First of all, on the open, we will be determining for the day whether we'll be sending buy or sell orders for this entire day. Then, during the bar close event, we will be visualizing the estimated market fill price, and then we will be sending every 15 minutes, 4 times an hour, 4 different algos. I would also like to mention that for every execution algo, we're adding listener on the status, and inside this event, when parent or child order gets filled, we will be accumulating implementation shortfall. And when the entire parent order is filled, we are adding statistics about the algorithm to main execution performance report. Now let's run the strategy. We'll be running the strategy for the universe of 4 tickers. Let me add a couple more: Goldman Sachs and Microsoft, for example. We choose the duration of 6 months, and I'll click on command start. So the strategy is performing its calculations, and we're visualizing all the relevant information. In the third pad, we are visualizing the average trade size, as we can see here, and according to our logic, we are producing the market impact curves, where we're seeing the different levels of execution depending on order sizes. But the main chart is execution cost chart, which represents cumulative implementation shortfall calculated for all the 6 months periods. So let's look at Microsoft. We're seeing that the blue line represents the minimum impact, which is the TVAP. Black line represents the limit to market combination. Green one is the VWAP, and red one is the minimum mean variance, which is the benchmark. And if I choose a different ticker, for example, Apache, then we'll see the picture is quite different. In this case, TVAP is actually greater than limit to market and TVAP. And if I scroll different tickers, we'll see the pattern is very different for different instruments. So what does it tell us? It tells us, like for example, for IBM, we're seeing that TVAP is worst out of all of them. So it tells us that for each instrument we could calibrate and optimize execution algo depending on the not only market conditions but depending on the historical profile of market data for this instrument. Now I would like to go to main execution performance report, which has 65,000 statistical observations for all execution algos, and I'll apply layout. This layout is a group view, first by instrument and then by execution algo. So if we look at detailed report, what we see is that while overall implementation shortfall for TVAP is in general is smallest for majority of instruments, but the risk or standard deviation is actually much better for VWAP proportional to implementation shortfall. And I'd like to illustrate this bar chart where I'll tell the system that I'd like to look at all the statistics side by side. And so I'll take implementation shortfall or implementation standard deviation, and we'll see the results of our calculations graphically. So side-by-side comparison for execution algos shows that there's a room for the calibration optimization of the execution algorithms for different instruments and different market conditions. That concludes the brief overview of execution algo evaluator. Thank you.